All right, so today, not a whole lot of work as far as, doing the actual math behind it. We are interpreting. We are making sure we understand the meanings, how we know what the heck it is we're doing. If we can do the math, that's great, but you got to know what you're doing. So it says you'll be required, I'm not going to read every single word to you, but you're going to be required to interpret the meaning in context of derivative and or definite integral on the AP exam. When interpreting these values, it's crucial, that means very important, that you are concise and include three components in the interpretation, okay? So when you're taking a derivative, okay, so a derivative represents a rate of change of something, right? So for derivatives, and we'll start right here so it sticks out, instantaneous rate of change of a function. It occurs at a precise moment because it's instant, right? It's not an average rate of change. You always interpret the derivative at a specific time, not during or over an interval. Also use the word rate in your interpretation. So there's three things to include for both of them. The noun, like the context, what the heck are we even talking about? Then the units, super important for independent and dependent values. So it has to be the time and the whatever. Make sure you put them both, even if you feel like you're kind of repeating yourself. And for derivatives, use the word at, because it's happening at an instant, because it is instantaneous. All right? For integrals represent accumulated amount of change that happens over an interval. So this is not at a specific time. We're accumulating something over time. So make sure you use phrases like over the interval and not at. Okay, so again, noun, what the heck are we talking about? Units for both independent and dependent value, and include the time interval. Okay, interval for this one. All right, so even though it tells us what to find, I gave you the answer, and then we're going to just do the interpretation here. Okay. So here we go. A local store opens at 9 a.m. The amount of people in the store can be modeled by this. So A of T, you make yourself little notes outside. A of T is people. PPL for people. It's easy. Where T is measured in hours and 9 a.m. corresponds to T equals 0, find A prime of 3. Use it. So we did that, boom. But then, because again, the calculator is going to do that part for you, and we're going to practice some more on that, but we're looking at the interpretations right now. Using correct units, interpret the meaning of the value in the context of the problem. All right, so if A of T is people, A prime of T, or A prime of anything, that's basically dA dt, right? Okay. So then your A of T was people. Your time, what time unit do we have? Hours. Okay, so this is people per hour is what A prime is going to be. So you can kind of make sure you have the right units and you know what the heck is going on before you just jump in and start writing stuff, right? What did I do with my... Did I set it down somewhere? Oh, I set it down right there. Sorry. All right, so what does this represent? The rate of people in the store? Okay, so is the amount, let's talk about the amount of people, is it increasing or decreasing? Decreasing, okay. So this represents the rate at which the amount of people are decreasing, right? Okay, so the amount of, this represents the amount of people, is decreasing at a rate okay, so if it's decreasing at this rate, do I use the negative? No, because I said decreasing. Good. So the amount of people is decreasing at a rate of 1.281 what? People per hour. That's why we figured that out. People per hour. Is that all we have to say? Yeah, it's fine. What else? we have to include time. So we have the units on the rate, right? We use the word rate because that was one of our stipulations. So we have the context, it's the people, right? It's decreasing. Units for both the time interval, we haven't talked about that. Oh, I'm looking at the wrong thing. We don't want an interval anyway, right? Units, and we have to use the word at. Yes. At t equals, what is it, 3 hours? Could it be 12 p.m.? Yes, starts at 9. What is it? I don't have to do the math. 12 p.m.? 12 p.m. works too. Always afraid I'm going to count the time wrong. Okay, so let me make sure I got everything. Yep. So we have the amount of people is decreasing at a rate of, here's our rate, at t equals 3 hours. We good on all that? What questions we got? Okay. Let's look at this one. Jill is jogging along a straight path. For t being between 0 and 25, Jill's velocity is given by this function. V of t is measured in meters per minute. So I'm going to write out to the side here for me. V of t is meters per minute. Keep up what the heck is going on. Using the correct units, interpret the meaning of this value in the context of the problem. So we actually found this integral. Now when we do the absolute value, what's the difference between using the absolute value here and not using it? This is the total distance traveled. So she could have run back and forth. It says along a straight path, but who knows if maybe she had to step back for something. So it's her total distance traveled because we're taking positive and negative and just putting it all together, right? If there wasn't an absolute value, then that would be her displacement, how far she is from where she started. Sometimes those are the same thing. Like if velocity is always positive, those can be the same thing, and that's fine, okay? All right, so we found this, and this is in meters, but even if we hadn't found it yet, okay, so let's say that we hadn't actually found that. When you take the integral, remember that this v of t, well, that velocity is meters per minute, right? That's where this comes from, this right here. Then dt, that's the difference in your time, that's times minutes. So when you integrate, those cancel out, that's what just leaves you with the meters there. Okay, does that make sense to you? Okay. The total distance, the total distance, what's her name? Jill jogged was 3381.996 meters on or over or for, however you want to say it, or we can say from. You can use this. I always feel like my words come out weird when I use an interval like that, so I usually say from t equals 0 to t equals 25, and what were our units? Minutes. So you check that you have units for both things. You check that you have a subject, that if it's an integral, it was over an interval of time and not just at something. What do we think? If there weren't, then I think that we would probably have maybe just a little bit more information because we don't know necessarily if velocity is always positive. If velocity is always positive, it's the same. If it's not, like I said, if she had to turn around and go back and get something, if there's no absolute value, then it's her displacement. It's her how far she is from where she started, where this gives you the total distance. Yes, exactly, yes. Because the difference here is this. Remember, this is an accumulation. So that's like, it's a bunch of areas that are added together, right? Those are your distances. So like if she ran 5 miles and then she had to go back home, she went back home, so she went to the right, then she went to the left, and then she went 10 more miles, your answer would be 10. She'd be 10 miles from home, where she actually ran 20 miles total. And so that's why when you take the absolute value, it puts the absolute value around all of them like that. Okay. Does that make sense? Okay. Good question. gosh, anything else? All right, so I want you to look at this next one. All right, for t being greater than or equal to 0, h is a differentiable function of t that gives the temperature in degrees Fahrenheit of a house in Houston in July, where t is measured in hours since midnight, using correct units. Okay, so before you do any of this, all I want you to do, you can talk to each other about this, is right to the left of A, B, and C, I want you to put what the units would be for each one of these things. Does that make sense? Just figure out what the units are for A, B, and C and write them out here to the left. Okay, sometimes it matters. Okay, that's a very good point. You said pause, we have a capital H. Does the fact that this H is capital have any bearing on anything? Yeah, so it says that this capital H is that. If this was a lowercase h, and this was a capital H, yes, 100%. So very good observation. Resume, unpause. Okay, so if this tells us H is differentiable, it gives us the temperature in degrees Fahrenheit, then for A, what are our units? Degrees Fahrenheit, right? Because it is what it is. This H prime here, okay, that means basically that is dH dt, right? And so that is your change in temperature, which is degrees Fahrenheit, over your change in time, which is hours, like so. That make sense? Okay, so here we're integrating, right? So since I'm integrating this H of t, that is degrees Fahrenheit, times, or parentheses, or whatever. I wouldn't use an x. That was a very good question. Like, what did you do? Did you use the dot? Use an x, you might confuse yourself like it's a variable. So just, I'd be careful with that. But then this change in time, that's hours. So you have degrees times hours, right? Divided by, what's this 8 minus 0? Time. So that's hours. And then that's going to give you degrees Fahrenheit. Because remember, if you're going to add up everything from 0 to 8, and then you divide by 8, what are we finding? What's the word? Starts with an A, but it's not area. If you add up everything and divide by how many there are, what's that called? Average. So this is an average of the temperature. That's what we're finding. So all three of these pieces here have units on them. Okay, this is temperature times time divided by time. That's why we get the average temperature here. And so if you understand your units, it will help you understand what we're trying to write. Does that make sense to you? And so, and different people are going to understand it different ways. I mean, to me, I like to figure out my units first, because then that really helps me make sure that what I'm talking about correctly. Clearly, this is just a temperature. This is a rate, right? This is not a rate. This is the only one that's actually a rate in what we have. Okay, we good on that? All right, so that means that H of 15, what does that actually give me? Okay. Okay. When t equals 15. Okay. So this is, so we don't know actually what the answer is, and that's fine because we don't have enough information. But this is the temperature of the house in degrees Fahrenheit at t equals 15, what? Hours? Could you also give a time there? Yeah. Yeah. 3 p.m., which is fine. But you know what? 15 hours is fine too, so you don't do some weird time thing. Okay. We got on that? All right. So then we have H prime. So that was in degrees Fahrenheit. We made sure we said that. We have H prime of 15 now. This is degrees Fahrenheit per hour. So this represents a what? Change. A what of change? Rate of change, okay? So I would say that this is the rate of change of what? Of the, give me a noun, of the, what of the house? Temperature. The rate of change of the rate of change, okay, sorry, my words, of the temperature of the house. Yeah, can you say what? Yes, you can probably word it a lot better than I. I think so. Because A-rock and I-rock are okay. I don't know. Use the words. The rate of change of the temperature of the house. I know. In what? Yeah, degrees Fahrenheit per hour. The rate of change of the temperature of the house in degrees Fahrenheit per hour. This is a rate. This is a derivative. So we have to say at when? T equals 15 hours, which is also 3 p.m., but that's too much thinking for me. And does yours have to be worded exactly like mine? No, it does not. I'll let you word your own on the next one, but because I want to talk you through some more. But it should be very similar. You need to make sure you use all the same places. Sometimes I start writing before I start thinking that it's a little too wordy, but I can get all the stuff in there. All right. So now here, we've already decided, because we made sense of the units, if you're going to take an integral, whether it's written like this or it can be written like this, yeah, but you can see it both ways. Like that's the same thing, right? That's dt. I'm sorry, my handwriting was getting better on this board, and then spring break happened. And so this is the same kind of thing, right? But this is just degree Fahrenheit. So this is the what? What's the word? Average. The average, but it's the average what? Temperature, because it's in degrees Fahrenheit. Very good. The average temperature. Yeah, I think so. That's fine. The average temperature of the house in degrees Fahrenheit when? Good. From T equals 0 to T equals 8 hours. You could say from midnight to 8 a.m. if you wanted to, but I would just go with the numbers themselves. Okay? What do you think? Oh, why is the rate gone? Oh, no. Oh, you know what? It's not on mine. Okay, I went in there and I fixed something else because things were weird, and then that is not good. So we'll fix that. This is the rate R. It's just capital R of T goes right there. Is yours wrong too, or is it just mine? My paper, before I change some other things, is right, but if you don't have anything there, we're there. All right, so now I want you to do just A. Come up with the units and come up with an explanation. Yep. So R of T is what they gave us, right? So we have gallons per minute. Okay, so if you have write something down for your explanation, I'm going to write mine down, and then don't erase. You don't have to erase yours and copy mine. If your words aren't exactly like mine, it's fine. Might be better. Okay, so I could say this is. So I put the rate in gallons per minute in which the water is gushing out of the pipe at t equals 5 minutes. If you basically said that, but your words are a little different, that's okay. Make sure you say that it's a rate, because you're given a rate. The units, you have to have the gallon per minute. What's happening, the water's flowing out of the pipe. Gosh, I used the word that was in the sentence, but it's leaving the pipe in some form or fashion at t equals 5 minutes. Flowing, that's fine. Because it is a flow meter, and yeah, flowing out, it's leaving. Whether it's gushing or flowing, it's leaving. That's the most important part of that, and yeah, it's fine. Totally fine. Okay, well, how we good? All right, y'all do B then. Come up with your units. Think about what it means. What are these fancy dice for? What do you do? Fun. Who runs the Nerd Club? Mr. Fuentes, yes. All right, so if this is R prime, this is going to be gallons per minute, then what? Per minute, okay, or minute squared either way. Or gallons per minute, or gallons per minute squared. Both of those things are totally fine. However you want to say it, either one is totally fine. But we have the gallons per minute, and then we're taking the derivative. That's why it's gallons per minute per minute. So this is the rate at which what's happening. Because these are both rates, right? This is the rate at which the water is flowing out. This is the rate at which what? The rate is changing, right? Which is weird, because basically our rate of change is changing. That's what's happening. So this, and again, your words don't have to be exactly like mine. Let's see, the rate, and I probably am not even writing the same as I wrote on my paper. The rate in gallons per minute. You don't have to erase yours if yours is different. The rate in gallons per minute at which the rate of water, I will use flowing this time, the rate in gallons per minute at which the rate of water flowing out of the pipe is changing. Okay? So that rate of change is changing. Go ahead. The rate of change, yes. Are we done? Am I done? No, I have to say this is a derivative, so I have to say at what? T equals 5 minutes. We good on that? All right. Questions about what you had if it was different? Yes. Perfect. Yes. Very good. Anything else? All right, let's do C together. Oh, I'm sorry. Yeah, go. What'd you say? I'll write it. Can I read it out loud? Oh, we're on this one. The rate of change of the rate at water in gallons leaving the tank per minute. I think you need to put, what I think needs to happen is your units. Get how you separated your units. You have gallon leaving the, I understand what you're trying to say, but I would say the rate of change of the rate in gallons per minute that are leaving the tank. Like put the units all together. Yeah, does that make sense? Okay. I think that shows a little bit better that you understand how the units work. So, okay. R of T, what's our units there? That's gallons per minute, right? And then the dt is minutes. The end is gallons, I know. It's how I'm answering the question, or asking the question. Okay. So then what is this? The amount of what? Okay. The water. The amount of water in gallons. The amount of water that's left in the pipe, or what? What is the amount of water? What's happening with this water? It's leaking out. So is this the amount of water that's left, or the amount of water that was there, or the amount of water that left? Okay. So the amount of water in gallons that flowed out, I'll say it like that. That's probably not good English, but something like this. That flowed out of the pipe. Okay, this is an integral, so this is from t equals 0 to t equals 5 minutes. Okay, so what does R of t represent? Gallons per minute. It's the rate at which the water is flowing out in gallons per minute, right? So if you want to really analyze the units here, this is gallons per minute times this dt, which is minutes, right? Those are going to cancel out, but then all that is over minutes. So we still have gallons per minute. When you're doing this, what's the word that the A that goes with this? Average. It's the average of whatever this is. So it's the average rate at whatever this is. Because you know when we integrate it, this is becoming the amount instead of the rate. But when you find the average, it is the average rate right here, whatever that is. So the average rate at which the water flows out, something like that. Flows out of the pipe in gallons per minute. Is that all I have to say? Nope. From t equals 0 to t equals 5 minutes. Okay, we good? Okay, so all those pieces, we want to make sure they're there. Now the next part's a little bit different. We're going the opposite way. They're telling us what it is, and we're having to just write the calculus notation because we got to be able to go in both directions here. So the rate at which water flows into a tank is given by R of t, measured in gallons per hour. Okay, so I'm going to make myself a little note. R of t, that is in gallons per hour. For t is greater than or equal to 0. If the tank initially holds 75 gallons of water, okay, so doesn't that mean that R of 0 is what? 75. Oh, no, that's gallons per hour. It's not. That's not what we're looking for there. The rate at which water flows into a tank. Oh, fine. Our initial amount is 75. Use proper calculus notation to represent each of the following. All right, so the amount of water added to the tank during the second hour of flow. So if R of t is gallons per hour, what do we do with R of t to get just gallons? Because the amount of water, that's asking me for, that's in gallons, right? What do we do with this to get gallons? Integrate it. So we're going to integrate R of t dt. And then what are my limits of integration? All I want is during the second hour, not from the beginning until 2 hours in, just what's happening during the second hour. So I'm going from 1 to 2. You see what it's asking you there? That gives you the total amount within that time frame right there. 2 to 2 would be 0. You're right. That's very good. All right, now we're looking for the rate. Okay, so this is a rate, but the rate at which the rate of water is flowing is changing. So if I want the rate of the rate, what do I do with R of t? Derivative. So I want R prime of what? 6, because it's at 6 hours. All right, so now I want the average. Oop, ding, ding, ding. So we have to do something, right? So I know that the average, I'm going to have 1 over something, and then I'm going to have to integrate something, right? The average rate of water flow over the time interval from 0 to 10. So this will be 10 minus 0. Yes, you could just put 10. 0 to 10. And then it's R of t dt. If you put it over 10, that's fine too. I just didn't because it's kind of small. All right, now I want the average. Okay, so I got average and I got average. The average rate of increase in the rate of water flow from 0 to 10. So I'm still finding an average. I'm still going from 0 to 10, so it's 10 minus 0. 0 to 10. Whew. What am I finding the average of? R prime. So, because the rate at which the rate is changing is R prime. So I'm integrating R prime to get that average. Because when you find the average, okay, so it's different. Like when I found, okay, R of t is gallons per hour, right? When I just plain old integrated, I get gallons. When I find the average, it's the average of this, so this is still gallons per hour, right? This one's gallons per hour. I want the average rate of the increase in the rate. I want the average rate of the rate. So the rate of the rate is R of t. And so I have to integrate R of t to get that. Does that make sense? And I admit, I get it. It's a little confusing why when I integrate this right here and I do this, I get gallons, and here I still get gallons per, was it hour? Remember, that's because when we do this, is R of t, that's gallons per hour times hours, right? Those cancel out. Here, we're doing gallons per hour times hours, and then dividing it by hours. So if you want to make sense of this one right here, R prime of t dt, right? So that's going to be gallons per hour times hours, right? So that those cancel out, and then you divide by hours again. That's the rate of the rate. Okay? That's why I think analyzing the units sometimes can help you wrap your mind around it if you're lost in what you're doing. Okay, let's do E, and then I'm going to let you do the rest on your own. The total amount of water in the tank at t equals 0 hours. Okay, yes. Yeah. Zero to 10, but yes. Because you have to start at 0. You're starting, well, because at time 0, you have the 75, but before the first hour, some water's going in or coming out, right? R of t dt, good, very good. You do not, because this says the whole time that water's flowing into. So no water's leaving, yeah. Good question. Yeah, I think we would have more information because there is going to be kind of an in and out kind of thing that we look at too. I think we'd have more information for that. So I don't think that part in this type of thing will be all that confusing. Hopefully, it's my impression anyway. Okay, we doing okay? All right, so now I want y'all to work on the rest of those on your own. We'll look at them tomorrow, and then there's some on the back too. Okay, you got this. Time is tick, tick, ticking away.